Hey, hi everyone. Welcome to my YouTube channel. My name is Sunny Savita, and I'm back with another exciting and important video. Guys, from past few days, I couldn't upload any video on my YouTube channel. It's not a days actually. It's been around 1.5 month. I haven't uploaded any sort of a video since I was busy with some of my family commitments, some of my other work and all. So I just took a break for 1 month, but it extended till 1.5 month. But don't worry, guys. Again, I'm back, and again, I'm going to start with my previous playlist itself. So in my previous video, I discussed about the corrective RAG, which was part of this LangGraph course only. So as planned, I will complete this LangGraph course, and I will try to discuss a different multi-agentic system and all, because currently multi-agentic AI or agentic AI, actually it is in a very like a buzzword, right? It's a very important as well to all of you. Everyone wants to know about it. Everyone wants to understand about it, right? So that's why I picked up this LangGraph course, and I hope so you learned so many things with respect to this agentic AI and all agents, how you can create agents. And before that, I uploaded so many videos with respect to the RAG, LangChain, and all. So without wasting a time, let's start with a video. Let's start like wherever we left. So first of all, let me give you the quick recap. Okay. So if you will go and check with my YouTube channel, you'll find out that the last video actually, which I uploaded, I think in November, right? So it was about the corrective RAG. Okay, we reached to the RAG part. There we have to create a different agentic RAG based pattern. If you will look in the syllabus, guys, so syllabus wise, I already completed this first slide. Then I completed the second slide as well, where I discussed the basics of the line graph. Okay, basics of the basically this line graph, like graph, state, nodes, edges, checkpointing, breakpointing, streaming memory, everything. Then I came to the next one. So I discuss about the different agentic pattern also, how you can structure your output, how you can create a React agent, how you can keep human in the loop, human intervention in the loop, and even I shown you one chatbot also, how you can create a chatbot using the LangGraph. Now it's time to discuss about the RAG, agent-based RAG, and I already started with the corrective RAG. So if you will go and check with my previous video, you will get that. Then after that, after this RAG, I will come to the multi-agentic system, and I don't want to wrap up this topic in a very short manner. I want to discuss this thing in a very detailed way. So definitely we'll try to discuss about this multi-agentic system and all in a very detailed manner, and we'll try to solve a couple of projects as well. So you can expect around 10 to 15 videos from my end. And parallelly, I was thinking to start about the fine tuning as well. So we'll try to start one more series that would be related, completely related to the fine tuning. Okay, so guys, many more things are about to come on my YouTube channel, and yeah, thank you for your trust, thank you for your support, guys. So recently I completed my 10,000 subscriber also, and it now it reached to the 11,000. So yeah, because in between I got so many messages, sir, why you are not uploading video, why you left this YouTube. Okay, your content was good, it was helping a lot. So guys, I haven't left the YouTube. Okay, I will be regular on my YouTube. Don't worry, but I just took a break because of some family responsibility, which I had to complete. Okay, recently I become a father. So yeah, and even I posted also in my community chat. If you will look into my community post, so there you will find out. See, I posted that again. I'm going to again. I will be back. So I'll be uploading the video from wherever I left, right? And yeah, I already informed to you, but last week, even last week, I got busy and I couldn't upload the video. So fine, not an issue. Let's start again with today's video. So today we are going to discuss about the agentic RAG. Okay, corrective RAG I already discussed. Now we'll try to discuss the agentic RAG, and then one more type of RAG is there, that is self RAG. Okay, and after this three RAG, we'll try to complete one project as well. That project actually is going to be based on the SQL agent, right? So first of all, let me show you the architecture of this agentic RAG, how this architecture looks like, and then basically step by step, one by one, I will show you the complete implementation of it. So this is the architecture, guys, which we have implemented in our previous session. And now we are going to implement this particular architecture. But before starting this architecture, let me give you the quick recap. Okay. And if you want to understand in detail, you can go and check with my previous video. So in the recap of what I'm doing, so here I'm going to write about the agents. I think everyone knows about the agents. What is an agent? So agents are nothing. Again, I'm saying agents are the powerful AI assistant. What is an agent? So agents are nothing. It's a powerful AI assistant. Now, why I'm saying it's powerful? So it is powerful because we are going to code this agent in a such a way, we are going to use the capability of LLM in such a way so that it can think in their own way. Okay. In short, I can say agents are nothing. Okay, we are going to use the capability of the LLM in such a way. So we are going to create a autonomous system. Autonomous system. Okay. Or we are going to create a co-pilot system using the capability of the LLM. Understood? I can give you the very basic example. Let's say we have an input, any sort of an input we are passing to the LLM, right? So what will happen, so first this input will come to the LLM and input, okay, based on this input, LLM will think, right? LLM will think. Then based on this thinking, okay, so here what we have a LLM. We are going to use the capability of the LLM. Okay, then based on this thinking, what will happen, it will take a action. Okay, it will take a action. Then based on this action, okay, whatever action, whatever output is coming, so again, what it will do the observation, means interpretation of the output. Understood? So it's happening until and unless we are not getting a reliable output. Okay, this everything is working in the loop. So we are trying to write our code, we are trying to write our logic in such a way. So this thing actually is working into the loop. And once this condition is going to be satisfied, means it's able to think about the question, it is taking a appropriate action, appropriate action, okay, appropriate action. Let me write over here. And whenever we are talking about action, guys, so in the action, it's calling a tool. Okay, and this tool are nothing. So I think now you can see the tools are nothing. Tools are the functionality. Tools are the custom functionality, and inside this function you can code anything. Anything means anything. Got it? Understood? So guys, this if this all the thing, right, if this entire process is going to be satisfy, then only will generate our final output. Understood? So here what we have done, we have given a capability to the LLM, so it can think, it can make a reasoning, okay, it can take appropriate action based on the given code, given logic, and then it can do the interpretation also. Interpretation of what? Interpretation of the interpretation of what? Interpretation of the generated output. Now, if the condition is going to be satisfied, then only we are saying this output is my final, this output is my final output. Okay. I hope this thing is clear to all of you now. Let me give you one very good blog so that you can go through with that particular blog and you can understand more about the agents. Okay. So guys, this blog actually, I will give you the link inside the description. This blog actually you will find out over the LangChain hub. Okay. Over the LangChain blog, inside the LangChain blog post. So they are talking about the LLM powered autonomous agent. And if you will look into the image, so this is the image, guys, which will tell you most of the thing, I think. So just a second. I seen one image inside this particular blog. There or not out. So yeah, so okay, it is like reflecting the same thing, like plan, execution, and all. Okay. Where is that image? Respect to the autonomous agent. Yeah, this one, guy. So this is the image, and now inside this particular image, you can see agents are nothing. It's a capable LLM. So capable LLM, how it is a capable? Let me do one thing. Let me copy this image, and I'm going to post it on my Blackboard itself. So see, this is the image, and agents are nothing. These agents are the LLM only. Okay, but this LLM, it's able to do the planning. It's able to do the take a action. Okay, tools basically it is always representing to the action. If I'm saying action means I'm calling any sort of a tool, so this tool could be anything, this one, right? And if we are saying like planning, so planning means nothing. Planning means thinking, observation, observation. Understood? And then reflection, self-critic, chain of thoughts, sub goals. Actually, it comes inside this reasoning. Okay, reasoning, planning, anything you can say. And the ultimate goal is nothing, just to think about the question, just to think about the input, and then make a correct observation. Understanding my point? Then we can handle the memory also. This is not a big deal to sustain the memory, to handle the memory, right? Long term, short term, both memory we can handle. And even I explain you this thing in my previous videos as well. So if you will go and check with my YouTube channel, you will like already find out the video, or you will already find out the series with respect to what, with respect to this memory. Understood? I hope so this thing is clear now. Coming to my architecture. So this was the architecture which I implemented in my previous session, and the architecture name was the corrective RAG. Corrective RAG. So inside this RAG, what we were doing, so we are starting from here. This is my starting position. Okay, input. And now again, guys, see, I'm explaining you very, very slow. So if you are thinking like it's a slow, you can increase the speed of this video. You can like watch it at 1.5x. Okay, it's a suggestion from my end. So here I'm providing an input, then it is going to the retrieval node. Retrieval node means what? So retrieval node means vector retrieval. So it's going to be retrieve the necessary document, and then it's going to be grade those document, those retrieved document, whether it is correct or not, yes or no. Okay. So let's say my document is fine, my document is correct. So what I will do, I will take this path, okay, this path, and I will generate my final answer using the RAG chain. Understood? Tell me. I think it's getting clear. Now let's say my output is not correct. If it is saying no, your document is not correct, whatever document like you have fetched, right? So in that case, what will happen? It will transform the query. It will analysis the query, the given query. Again, we are going to use the capability of the LLM over here, right? It will analysis the entire query. Then we are going to fetch the answer from the web. Okay, web from the web, and then finally we are going to generate the answer. So start means we are passing an input, end means we are getting an output. Pretty straightforward architecture, and this is called the corrective RAG. Okay. So if I'm saying corrective RAG, self RAG, okay, or if I'm saying agentic RAG, agentic RAG. So here what I'm doing, we are going to implement a agentic pattern only. Agentic pattern only inside the RAG pipeline. Okay, so to this corrective RAG also you can say it's a agentic RAG. To the self RAG also you can say it's a agentic RAG, agent based RAG. To this agentic RAG means you will hear this particular term, right? So agentic RAG, obviously it's a agentic RAG only. So what I want to tell you over here, so if you are hearing about the corrective RAG, self RAG, all are nothing, all are the agentic RAG. Means we are going to implement the agentic pattern inside our classical RAG. Okay, and whenever it's coming to the agent, so what is the meaning of it? The agent are nothing, it's a powerful AI assistant which can think by themselves, can take a observation, okay, which can sustain the memory, which can call the appropriate tool according to the action. So here we are giving a more capability to our LLM. And how we are giving it? So based on the certain logics, okay, based on the certain instruction, we are giving a more capability to our LLM. Now, in this video, which architecture we are going to implement? So here, if you will look onto my blackboard, you'll find out one more architecture, this one. So I'm going to start from this point. Okay. Again, it's a agentic RAG. Okay. So I'm going to start from this point. This is my input. Then it is coming to the my assistant. This my assistant is nothing. Here I have my LLM. Okay. This LLM actually, what it will do, it will take a decision. What should I do? Should I call the tool? This vector retriever is nothing, it's my tool. Okay, this is the label. Label is saying this vector retriever is nothing, it's a tool. Okay, so guys, let's say like I came over here, I came to this point, and here I my assistant means my LLM actually is going to decide. So for this particular question, you need to call the tool, means you need to extract the document from the vector database. Okay, so I'll be extracting it. Then here what I'll be doing, I'm going to be generate it. Okay, there is my generator, and finally I'm going to generate it. But directly I'm not going to generate. First what I will do, I'll be checking, right? I'll be checking over here at this particular point. So whatever I have retrieved, okay, whatever I have retrieved, basically, so this is correct or not. I will try to make a grade, okay, whether it is correct or not, yes or no. So if it is saying no, it is not a correct. So what I will be doing, I will be transforming the query, and then again I am passing it to the AI assistant for generating a final output. If it is saying yes, this document, whatever you have retrieved, it is correct, then what I will do, I will come to my output generator, and then finally I'll be getting my output. Okay. So I hope this thing is clear to all of you. Now, once I will be implementing it, you will get a more clear-cut idea. Okay. Again, I will come to this particular architecture, and you will be able to understand. But let me give you the quick revision. So let's say here's my input, here is my LLM. Now LLM is deciding, should I need to call the tool or should I need to end this process? So let's say I'm coming to the calling tool. I'm calling the tool. Okay, from the vector retriever, I'm fetching the document, and here I'm going to decide whether my document is relevant or not. So let's say if document is relevant according to the query, according to the input, then finally we are going to generate it. Okay. Now let's say if it is saying document is not correct, right? In that case, what I'll be doing, I'm going to transforming this query, and again I'm passing to the LLM for generating a final output. So in the previous architecture, you will see we are passing this particular query, transform query, to the web. Okay. From the Google, actually we were fetching out the answer, and then we were generating over there. But here we are not doing this thing. What we are doing, after transforming the query, after analyzing the query, we are again passing it to where we are again passing it to the LLM. Okay. So here LLM will take a decision again what needs to be done. Means after the analysis, so let's say I asked a very simple query, any specific query, so it will again go to back to the LLM, and maybe LLM will generate a normal answer, or LLM will not generate anything. It will say, okay, it is my out of scope, I don't know about anything, because it is not related to this it is not related to this vector database document. Whatever you have stored inside the vector database, it is not relevant to that. Understood? Now let's try to code this particular problem, how we can do that. So for coding this particular problem, uh, I'm going to use the same folder. Okay, this LangGraph end-to-end, and this is also available on my GitHub. Right, I will give you the link inside my description so that you can download all this code. Okay, all this files and folder. Now inside this LangGraph end-to-end folder, I created one more folder. My folder name is what, agent based rag, and inside my this folder I already kept this corrective rag.ipynb. Now inside this folder only I'm going to create one more file. My file name is going to be agentic underscore rag, okay, dot ipynb. Understood? Now, what I'll doing, so I'll be like selecting a kernel. If you don't know about this setup, you can go and check with my previous video. There I already explain you this entire thing. Okay. So here, guys, what I did, I created a file. Now inside this particular file, I am going to write a further code. Now let's start with the coding. So first, guys, I'm going to import couple of library. Here I'm going to import warnings. Okay, so if I will be getting any sort of a warning with respect to my import statement and all, so I will be able to like remove that, okay, from the console itself. So now warning, actually it is having warnings. It is having what? It is having one uh it is having one method. The method name is filter warning. To this one I can pass this ignore. Okay. What I'm doing, I'm going to be executed now. We have other import statements. So I'm going to write each and every import statement in a single shot itself. So these are the import statement, guys. And don't worry if you don't know about this import statement. So it's going to be clarified. And if you have seen my previous session, then I already used couple of import statement already there. So I hope so you will be familiar about this annotate, okay, this type date, then str output parser, human message and base message, then this pydantic object. What is a pydantic object? I already explained you this thing in my previous sessions. Okay, so let me import it, and I think so. I'm able to import. Then what I'll be doing, I'll be setting up each and every query, sorry, each and every key, right? Whatever keys and all it is whatever keys and all which is required to me. Okay, let me execute it again. Yeah, so I'm not getting any sort of a warning. Now what I'll be doing here, guys, I'll be like loading all the keys, whatever keys is required. So these are the keys from the Google API. Okay, Google API key, why it is required? So that I can load the Google based model like this. Okay, Gemini Pro, Gemini Flash, because Google AI Studio gives you the model which you can consume freely. Then we have Tableau API key. Tableau API key just to scroll the web. I can crawl the web. Grok API key, again read to the model. And here over the Grok also you'll find out many open source model which you can access freely, and it is for the faster inferencing. Then we have LangChain API key for what? For configure the LangSmith. Then we have this langchain trace v2. This is the nothing. This is the again configuration for the langsmith. Okay, we are going to trace each and every execution. And then here we have this langchain endpoint. So at this particular endpoint, actually you can get your all the logs, right? So this is what this is the this three variable you will get from the langsmith only. I already shown you in my langchain videos. You can go and check out over there. And this is very important. These keys are very important. And I already have this key inside my .env. I already kept this key inside my .env file. Now what I can do, I can, okay, just a second. By mistake, I closed it. No issue, no issue, no issue, guys. And again, open it. And here is what. So what I was saying, I already shown you how to access this key and all. You can go and check out. Now coming to the next part. So I have this import statement and all everything. Now it's time to write a further code. So after this one, what I have to do, I have to like showcase you how you can create a retriever first. Okay. Now before creating the retriever, let me do one thing. Let me load the embedding model. Okay. And let me load the LLM model as well. So what I'm doing here, I'm going to load my embedding and the LLM model both. This is fine. Perfect. Fine. Now I think going to work. Just a second, guys. Let it complete because it is going to be connect to the kernel. Yes, it is done. Oh, this is also done. And let me write the this is the key. So here what will come now, the Hugging Face and this grok will come because I'm going to load the model from the open source platform. Okay. So this is my embedding model and this is what this is my LLM model. Which model I'm using? I'm using this Zima, right? So let me load this two model, embedding and the LLM model both. So I'll be using it for creating a RAG pipeline. Now, what is required? So see, if you want to check out this LLM, if you want to test whether it is working fine or not, so simply you need to call the invoke method. Okay. So simply you need to call the invoke method on top of it, and you can easily test it out. So you can write over here, hello, how are you? How are you? Okay, so after loading the model, I will execute this llm.invoke. You will find out that it is generating a output for me. Then after this one, what is required, guys? So for creating a RAG, I require the data. If you don't know about the RAG, you can check out with my previous video. I already explained you so many things with respect to the RAG, even advanced playlist and all, everything I uploaded. Okay. Now coming to the next part. So how basically we can collect the data, from where we are going to collect. So on top of the same blog, okay, on top of this particular block, I'm going to create my RAG system. So how to load this data, how I can capture this data, let me tell you that as well. So this data actually I'm going to load using what, using the langchain itself. Okay, so inside the langchain actually we have one class. The class name is what, web loader. I already imported it over. So let me take this particular class web-based loader, and I'm going to create an object of this particular class. And then inside this object, I'm passing this URL. And then I'm going to load the data. So simply I need to call this load method. And here what I'm doing, I'm going to be collect this particular thing inside where, inside one variable. Okay, I'll be collecting that. So first of all, let me tell you what all thing actually is going to be written. So if you will check over here, so it is going to be written me a one list. Okay, let me fetch the data from this list. So here is 0. Okay, this is the object, document object. And if I want to check that what all thing we have, okay, inside the document object, so simply you can call the metadata over here, metadata. So once you will call this metadata, guys, you will find out all the keys, like source is there, title is there, description is there, language is there. So inside this description only, it is going to be capture the entire data. And again, it is not going to capture the images table. It is just going to be capture the text. Okay. If you want to capture the images tables, so for that the logic will be different, and we'll have to use the different library. Got it? Now what I'm doing here, so here I'm going to be check with the description. So simply I can check with the description because it is nothing, it's a dictionary only. I can write this description over here. Let me take this description, so that what you will get the entire data. Okay, that whatever data actually, whatever text is going to be fetched from there, this one. So I hope so this thing is clear, how to take a data from the internet. Okay, how to take the data from the URL. Now what I'm doing, guys, I'm going to fetch the data from two URL. Means this is the first URL agent, and we have a similar blog. Okay, the blog name is what? The blog name is prompt engineering. So the first blog was related to the agent. The second blog actually it is related to the prompt engineering. I'm going to load it. I'm going to load all the URL, and here I'm going to perform the list comprehension. So once I will perform the list comprehension, guys, see here is my list comprehension. I'll be getting what I'll be getting. Tell me. So let me print this docs. I'll be getting my both document object. Okay. Now what I have to do here, I have to divide this data into the chunks. How I can do it? Let me tell you that as well. So for dividing the data into the chunks, see, if you will look into this doc, so what we have here, we have this nested list. Okay. But I don't want this nested list. I want a single list, and inside that particular list, we should have this document object, right? So what I'm doing here, I'm going to be write one. I'm going to write what? I'm going to write one more logic. Okay. I'm going to iterate on top of this docs. So here I'm writing for sub list, for sub list, okay, in docs. So what I'll be getting, guys, I'll be getting the list, right? I'll be getting the list inside this sub list. Then again I'm going to iterate the for loop on top of it. So here I am writing item, okay, item in what? Item from the sub list. So this is what I'm getting, and here what I'll be doing, I'm writing this item. So see what I'm getting now. I'm just getting a document object inside the single. This I will be providing where I will be providing to my recursive character split. Okay. So this thing I can capture inside one more variable. So here my variable name is what? Doc list. Okay. Now what I have to do here, I have to define the recursive character text splitter. So this is one type of text splitter, this recursive character text splitter. Actually what it does, it divide the data. Okay, it divide the data into the chunks. Okay, and chunks is nothing. Chunks is just a collection of tokens, right? If saying, if you are saying like if you can directly compare this chunks with sentences. We are going to divide the data into the multiple sentence, and if you can direct, and you can directly like compare this like tokens with the words. Okay, so sentence are what? Sentence are collection of words, and if you're saying chunks, chunks are collection of tokens, right? Both are same. Tokens is equal to word, chunks are is equal to sentence. So we are going to create our chunk size. The in each chunk actually will be having 100 tokens, and this is the overlap value. Okay, so I can write overlap value 25, means 25 chunks, sorry, 25 tokens is going to be overlap between the different two chunks. Okay, between two different chunks, 25 tokens is going to be overlap. Okay, so this is fine. Now what I can do, I can like divide my data. Okay, so for dividing this data, I just need to pass this document list to this particular method, split document, and here I'll be getting my document. Okay, split it data. So this is my complete data, which I divided into the multiple chunks. Okay, I hope you are able to understand it. Now we have to store this data inside the vector DB so that I can perform the retrieval operation on top of it. So this is my code for what? For the vector store. And which vector database we're going to use? We're going to use the Chrome database. Okay, you can use any database according to your requirement, but here we are going to use the Chrome database. We have a vector database, and now on top of this vector store, I'm going to call this vector, I'm going to call this as retriever, so that I can use this particular like object, this vector store, as a retriever only. So I hope so this is fine. Now one more thing I would like to tell you. See, here is what? Here is my retriever. But as I told you, whenever we are talking about agents, so in the agents actually we require tools. Okay, so we have to convert this retriever into tools. Getting my point? Because agents always call a tools, right? And what we have to do, we have to convert this retrieval as a, we have to convert this retrieval into tools. Okay, so for that we have a simple like method. Okay, it's not a method actually, it's a class, create retriever tool. Okay, from the retriever actually we can create a tool. See, I already imported this class over here, create retriever tool. From where? From the langchain itself. Understanding? Getting my point? It's very simple, very easy. Now what I'll be doing here, so here I'm going to convert this retriever into a tool. So let me take this retriever, I'm passing it over here, and I can pass the other thing as well, means I can pass some description, and even I can give the name of this particular retriever. So let me do one thing, let me give the name and let me pass some description with respect to this retriever. Okay, so I already written it. So see, here you can see this is the this is what? This is the name, retriever blog post. Okay, and here is what? This is the description. You can write any sort of a description. I written it. I written the description. Okay, you are a search tool which is going to be fetch the information from this, but this that block. Okay, so now I think so everything is clear to all of you. Now what do we have to do? We have to collect this particular value. Okay, we have to create an object of it. So we are going to collect the value of this object inside this variable retrieval tool. Okay, and then here I'm going to use this retrieval tool as a tool. Okay, so let me keep it inside the list. See, in this particular format only we have to keep our tool, right? And this thing I already explained you in my previous videos. So in this particular format we have to keep our tool. Now whenever we talk about the LangGraph guys, so inside the LangGraph we cannot use this tool directly. Okay, we have to use it in terms of the functionality. Okay, in terms of functional. So and inside the LangGraph, what is a function? Function are nothing, it's a node itself. Okay, so what I'm doing here, I have one more class, tool node. Okay, this is specifically for the LangGraph. Okay, if you're not working for the with the LangGraph, then you can skip this particular part, this particular like a step. And here I'm working with the LangGraph, so I will have to convert this tool into the node. Okay, because I have to arrange everything into the node and edges inside the LangGraph. So let me take this tool, and here I'm going to create a tool node, right? Tool node. So after doing it, what I can do, so after doing, so let's just a second, this one. So retriever tool, actually I'm passing it over here, and what I'm doing guys, tell me, I'm just going to be create a tool node. Okay, so I can use this particular tool node anywhere inside my LangGraph workflow, right? So this tool node is going to become now retrieve. I'm just going to be assigned this particular value inside this variable. I hope so everything is fine, everything is perfect. So we just have performed the data ingestion, and we have converted our retrieval into the tool. Okay, this is the way for converting retrieval into the tool. And finally, I assign to the tool variable. Now we have done one more thing just for the LangGraph. So I'm converted this retriever tool into the tool node. So I can connect edges to this particular node. Okay, I hope so. This thing is getting clear. Now let's understand the next part. Okay. So now guys, we are going to create a different functions. The first function is going to be AI assistant. Okay, so let me write over here AI underscore assistant. Now through this AI assistant, what I'll be passing the state. Okay, if you remember guys, we have created this state. Okay, in my previous session as well, and I think I clearly explain you what is the meaning of this state. State is nothing. State actually it's a structure object, and using this structure object, what we are doing, we are passing the input throughout the workflow. Okay, that's a simple meaning of the state. Now what I'm doing, so this state type is going to be a agent state type, agent state. Okay, AGENT STAT, right? And here what I have to do, I have to define this agent state class. Okay, so this agent state class actually is going to be my structure object, and always I will be taking an input in this particular format only. So here I'll be like what I'll be doing, I'm going to be inherit this type dict. Okay, because each and everything I'm going to be collect in the form of dictionary, right? So the structure of this particular class, like in whatever format it's going to be taken inputs, it will be a dictionary only. So here I will be connecting the messages, MESSAGES, and here I have to define what type of the message. Okay, what type of message basically I'm going to be collect. So this is the type of the message. So the type of the message is very simple. List of it will be a sequence of the messages. Okay, it will be a sequence of the messages. If you want to understand this agent state in a more detailed way, I kept one article, okay, related to this one, so you can go through with it. I'm just pasting it over here. So this is the complete article guys, this one. So here I talked about this agent state, okay, and the meaning of this particular notation. So what we are going to do here, we are going to be define the agent state, which is inheriting this type dict. And what is the use of it? The use is very simple, just to define the structure. Okay, in which structure actually we are going to collect the input, right? So this is just for the validation purpose, and how we are going to collect the messages. So see, in this format actually we are going to collect the message, means first message one, then message two. So you can see over here, this agent state is nothing, it's a sequence of messages, base messages or messages. And this add messages actually it is representing, we can add on or we can write as many as messages. Okay, list of messages. Understood? Tell me, this thing is getting clear? So you can go through with this particular article. Okay, the complete article I have pasted inside the notebook itself in a markdown format. So you can read about it. Then the summary, inside the summary also you will find out the complete detail of this agent state. Now we have a agent state, and here we have this AI assistant. So as of now, let me pass. Okay, let me skip this code. And now we require the next method. Okay, the next method is going to be what? The next method is going to be a grade. So using this grade, actually, we are going to be grade the document, whatever document we are going to retrieve from the agent, from the retriever node. So this is my grade. Okay, grade class. Again, I will be collecting a binary score, and this field description, these are nothing. It's a metadata, right? So why I have written this thing? So just to make sure the this data, whatever is coming to this particular variable, it should be a valid, right? Then here I'm going to define one method. The method name is what? Grade underscore document. Okay, document. And here I am passing this state, and then it's going to be a agent state. Type of it, it's going to be agent state, and let me write the pass over here. I think this is perfectly fine to all of you. Now coming to the next part. So now I have to create a generate. Okay, so here I'm going to create one more function, generate. So this will generate the output. Okay, so this is here I will be writing my rag chain, and again this is my agent state, and let me write the pass over here. Got it? So great document, great. Okay, this is the type of, this is the type. Okay, what type of output basically I will be getting? I will be getting this binary score variable. I'll be having this binary score variable, and the type of the binary score variable is nothing, it's a str, whether it would be yes or no. Got it? Then guys, after creating this generate, we have to write one more method. The method name is going to be rewrite, just to transform the query. Okay, so the method name is going to be a rewrite. Again, it will take a state, and here I will be writing this agent state. Now let me write the pass over here. Understood? So this is my method which I am going to be write, which I am going to be defined just to create my agentic flow. Okay. Now I hope so this is perfect. Now what I have to do here, I have to create a nodes. Okay, so this is my all the nodes. So AI assistant, basically it will be called my AI assistant. Let me mention it over here, this one. Then this retriever, actually this retrieve. Okay, I already created a node. This will be called the vector retriever. This retrieve is one of the node. Okay, and it will be called what? It will be called the vector retriever, right? Then what we have this generator. Okay, so let me write this generator over here. Just a second. So let me take this generator from here and let me paste it after this one. So we have a generator. So this is the output generator, right? Then we have a rewriter, means it will be transforming the query. Understood? So I hope so this thing is clear. This is my function, and this is the name of the function. Okay, so going forward, we are going to define this name of function just to access this particular function. Now what I can do, I can execute it, and I can create my nodes, right? I can add my nodes inside the workflow. Then what I have to do, I have to add the edges. So I'm going to be at the edges. So here what I'll be having this AI assistant. So the in process going to be start from this particular node. Okay, and then this is my next method. So whatever input I'll be getting, I'll be passing to my AI assistant. Now let me execute it. Got it? Then what I'll be having the conditional edge. Conditional edge, why conditional edge is required? So if you will look into this diagram, you'll like clearly see if my question is related to the document. Which document? The question is related to this agent and this prompt engineering data. Okay, prompt engineering document. So it will call the tool just to retrieve the information from the vector database. If it is not related to this one, it will come back to the end. Okay, so whenever you are seeing this dotted line, guys, this dotted line actually it is representing to the conditional edges. Means we have certain condition over here. Based on that particular condition, we are going to make a decision. Okay, so here I'm going to create one conditional edge. So this is my conditional edge. It's a pretty much straightforward. See over here. I'm saying I'll be starting from my AI assistant. Okay, I'll be starting from my AI assistant. Then I'll be calling this tool. Okay, this tool condition. Actually, we can create this tool condition. We can define this method from our end. If you have seen my previous session, I created one method over there. The method name was should continue, right? So should continue inside that particular method. I was writing my own logic, but here I am importing this method from the LangGraph itself. LangGraph is also given to you the tool condition where simply you can call this method, okay, and you can define your condition. So here is my method tool condition, which is taking a which what it is doing, it is taking a like decision. So should I call this vector retriever? Okay, or should I end the process, right? Should I call this vector retriever or should I end the process? So vector retriever is nothing, it's my tool. Okay, and here end means we are going to end the process and finally we'll be getting the output. So let me run it, let me execute it, and let me show you the other stuff also. So this is the first conditional edge. Then we have another conditional edge. Okay, this conditional edge actually it will come to this particular part. See, whenever we have a vector retriever, now let's say it's coming to the vector retriever, now we have to grade the document after getting output from the vector retriever. So if the output is correct, okay, it if the output is correct, if the output is relevant, what I'll be doing, I am going to be generated finally, right? If the output is not correct of this vector retriever, what I'll be doing, I am going to be rewrite the query. Okay, I'm going to transform the query, and after transforming the query, what I'm doing, I'll be like passing it again to the. So here, see, if output is correct, I'll be stopping this process. I will end this process. If output is not correct of the retriever. Okay, what I'll be doing, again, I'm passing the query to my AI assistant, right? Again, I'll be writing the query, I'll be rewriting the query and then passing it to the AI assistant, the final solution. So I hope so this thing is fine. Now, if you want to visualize this particular thing, this entire thing, so first of all, you will have to compile this particular workflow. Let me compile it. So here I can write workflow dot compile. Okay, and here CMIPLE, then I have to assign this particular value inside the app. So now it got compiled, and then if you want to see, if you want to visualize it, okay, for that I required this piece of code which I already shown you, right? So here I'm going to be display this entire process and you will be clearly see what we are going to do. Okay, so here we have a my assistant. So either it's going to be and or it's going to be called the tool. Then let's say if it is coming to the vector retriever, then what it will do, it will check, okay, whether it is correct or not, right? Whether my output is correct or not. So if my output, see, we have this conditional edge, no? Dot means conditional edge. So once it will come to this vector retriever, what it will do, it is going to be check whether this document is relevant or not. If it is relevant, it will generate output and it will end the process. If it is not going to be relevant, then it will come to the query rewriter and again it will go back to the AI system, right? If you're not able to get it over here, let me do one thing. Let me explain you over the blackboard itself and then finally we'll try to start with the execution. So here, see, again, let me give you the flow. So let's say whatever input is coming over here, this one, whatever input is coming over here, I'm checking it with the AI assistant. I'm checking with the LLM over here. Okay, this one. LLM will take a decision. Should I go over here or should I go over here? Dotted means conditional edges. Then I'm calling to this vector retriever and I am getting my document. Now I'm checking whether this document is relevant or not. Yes or no. So let's say if this document is relevant, I'll be coming to this path. I'll be generating output and finally I will end the process. Okay, but now let's say my document is not relevant. I will come to this path, okay, and I'm going to be rewrite the query and finally I'm giving to my AI. This is the whole sort of a process, a very simple process. Okay, and you can see in the same way actually we have coded this process. Now if you will ask to me, Sunny, where you are going to be grade this thing, so here I'm going to be grade this particular thing inside this method, grade document method. Okay, using this particular method I'm going to be return either this generator or this rewriter. This generator is a key, it is having this value. This value actually it is directly associated with this generate function. Here we have a key, okay, rewriter, which I'm going to be written from this grade document, and this query rewriter is again it is associated to this rewrite function. Okay, so likewise this entire thing is working. Now we just have to write what, we just have to write the functionality inside these particular method, guys. So let's try to write the functionality of these particular method. Okay, so guys, here you can see this is my first function. What I mentioned inside this function, see, it's very easy. It is very easy to understand. First we are going to fetch the message. Okay, as I told you, this is nothing, this is my dictionary, right? So we are going to collect the message in the form of dictionary, and this message actually it's a key and we have a value will be nothing, it will be list of messages. Here we are going to be collect those message, okay, and we are passing this message to this model. Okay, so here I am calling this LLM.bind tool. So we are going to bind the tool to this LLM, and LLM will take a decision. LLM will take a decision like which tool I need to call, right? So based on this particular message, actually it's going to take a decision, and here I'll be getting my response, and finally I'm going to return this particular response. Now this response will go where? This response actually it will go, tell me where, it will go to the tool. Okay. So here first what I have to do, so I already created a I already created a tool. If you will like scroll up and if you will check with the code, see I already created a tool. Okay, this tool. And with respect to this tool, I already created a node as well. Getting my point? So this is what, this is my retriever tool. This is my retriever which I created on top of the vector database. This is my retriever tool. Okay, this basically which I created using this particular retriever. Now this retriever tool actually I'm using at two places. Okay, so first as a tool which where actually I'm binding it to the LLM.bind tool. Okay, I'm passing this particular variable. The second actually I'm using this retrieval tool as a node, right? Node where inside the LangGraph workflow. So if you will look into the LangGraph workflow, I already use this particular tool node. What is the name of it? Retrieve. Okay. So let me scroll down and let me show you the flow. So this was the flow, guys, which I created, and this node. Okay, I'm using this retrieve actually as a node, and this is the name of it, vector retrieve. So where this response will go now? This response will go to the tool, means this response will go to the vector retrieve. From there we are going to fetch the similar output. Okay, so based on this question we are going to fetch the similar document from the vector database based on the similarity search. We are aware about the RAG architecture, so let me show you the RAG architecture. Here I'm going to import the image. uh, I think so I already created a RAG architecture. Let me check it out. RAG with memory, RAG, and that RAG architecture I shown in my previous. Just a second. Advanced RAG. This would be the one. No, guys. Thumbnail. Just a second, guys. Give me a second. So this is my RAG architecture. I was having the data. I already shown you this data. Actually, we took from where? From the document itself. Then we are going to make a chunk out of this data. Okay. Then we are going to be create an embedding. I already given the embedding model. Here you can see. If you will look into the retriever now, I already given the embedding. Where? Here. This one. This is my embedding from the Hugging Face. Then what I did, so here guys, I stored this thing inside the vector database. This is my chroma. Now whenever the question will come, it will going through the AI assistant. Okay, and this AI assistant basically it is giving to the tool. And what is my tool? My tool is nothing, it is my vector database only. I'm using this vector database as a retriever, and that retriever I'm converting into the node. Okay, as a tool I'm using that. Understood, guys? Tell me, is it like clear to all of you? I think so now. So we'll take a relevant document from here. We'll take a relevant document, and after taking the relevant document, what we'll do, we'll check whether this is really relevant or not. Okay, so here what I'm going to do, I'm going to write a further code. Further code for what? Further code for this particular function, grade document. Okay, so I fetch the data from the retriever. Now I am going to uh, grade it, whether it is correct or not. So for grading, again, we are going to use the capability of the LLM only, and see here is a very simple code for the grading document. Let me give it to you. The code is a little huge, so I'm just going to be copy and paste. This is the function. Now if you will look into this function, see we have this grade document. Here is what, here is my state. Okay, state is nothing, like through the, like using this state only, we are flowing the input throughout the different. Then it's going to return two things. First is output generator, and then second is a query rewrite. So what we are doing, see, first we are calling this with structure output on top of this LLM. So my LLM will only give me either yes or no, okay, based on this particular structure output. This I already shown you in my agentic pattern. Okay, if you will look into my LangGraph playlist, then here I define the prompt. So inside the prompt I'm saying, okay, take a question, take a context which is being generated from the retrieval document, okay, from the vector database, and then check whether it is correct or not. If it is correct, give me yes. If it is not correct, give me no. Okay, so with respect to this question, I'm going to check the context. So this is my complete pipeline chain. Okay, and here what we are passing it to the chain. Okay, what we are collecting the first message. First message is nothing, it's my question only. Then we are going to collect the last message. This is nothing, this is the tool generated message. Okay, inside the list we having two message now. First is a question, second is the tool, because as I told you, inside the list we are going to collect a message. Okay, this message is nothing, it's going to be a sequence of list. Okay, sequence of message. Understood? So from there itself we are going to collect the data. Then whatever output will come, we are going to collect the binary score from there, and we are checking. If score is yes, means document is a relevant document, then we are going to return a generator. Okay, this key I already created. If you will look over here, I already created this generator key. So it will fetch the value, this output generator, and this output generator is nothing. This is my generate method. Okay. Now I will come to this. And if it is not going to be a relevant document, then it will print document is not relevant. Then what I will be doing, I am going to be return this rewriter key. So it will come to this rewriter key. Okay. Then what it will do, it will return this query rewriter. Where is my query writer? This is my query rewrite. Okay. So it will rewrite the query using this function. As simple as that. A very, very simple orchestration. That what I have to do. See, finally, once let's say if the document is a relevant document, I am going to be generated. Okay, so let me generate this particular document, and here is a complete code for generating. Here we just need to define the simple RAG chain. Okay, so let me give it to you the code. So like it will generate, I'm printing the message. So here I'm going to be collect the message. Okay, and then you will find out we are going to be collect a last message, which is nothing, which is my document only, which is I'm getting from the tool itself. Then here is my prompt. So over the langchain hub, you will find out the different prompt templates. So this prompt template actually I am going to be collect from the langchain hub itself. Let me show you what we have inside this rack prompt template. I'm not going to write a prompt from my end, I'm just going to be collected from there itself. Now, what I will do, if I am going to be call this pretty print on top of this prompt, okay, you will find out this prompt in a like more structured way. See, this is my like prompt. Here I am giving my question. Here I am getting my context. Here I will be passing my context, and based on that, I'm going to generate an output. Okay. So here, see guys, what I'm doing. I'm going to be collect a message. This one is my question. This is my document. Okay, which I'm going to be collect from the same message dictionary. If you want to check the detail, you can check it out, you can print it, but I'm not going to print. At the end I will be getting the entire output. So I'll be showing you what I'll be getting. Okay, means at the final output, and how my state is behaving, okay, throughout the different nodes. Then here what I have to do, I have to rewrite the query. So this is a simple code for rewriting the query. Let me pass it over here, this one. Now, here I'm going to be transform the query, and after the transformation, again, it will go back where it will be going back to the AI assistant. So AI assistant will take a decision whether it needs to generate or not. Okay. So let me execute this as well. Now everything is ready, everything is fine. So let me go back to the code again, and let me show you from scratch. So this is my AI assistant, guys. Okay, this is my agent state. This is my AI assistant. Then this is my grade. Here I am going to grade my document, which I am going to be generate from the retrieve node. This is my prompt, which I am passing for generation the final answer, final content. Okay. Then here is what, here is my rewriter. If and that something is not going to work basically, so what I'm doing, I'm going to be rewrite the question, I'm going to analysis that, and I'm giving back to the AI assistant just to make a just to like write a answer. Okay, then here is my complete workflow, guys. This is done. Then ages connection is done, right? I compiled it. Now I have display it, right? Now what I have to do, I have to just call it. So how I can call it, I can simply call this invoke app.invoke, and here I can pass my message. I can pass any sort of a message, so I can simply pass it over here. What is a agents? Okay, so one more thing, guys, I need to pass a message in a in a structure format. I cannot directly pass the message like this. I need to pass the message in this particular format. Okay, in this particular format, in the key and value format, because my state type is nothing, it's a key and value, right? It's a dictionary. So here is my question, what is a autonomous agent? So let me execute it. See, it is calling the agent, means it is calling my what it is doing, it is calling my AI assistant. Then it is going to the document, it is checking document relevancy, it is saying document are relevant, then it is generating output. So see, this is my final output. Okay, I'm getting my final output over here as a AI message. Now let me show you how this entire agent state is behaving, and how I am getting my final output. Okay, so what I'm doing, I'm going to be copy this particular message. Okay, just a second, copy it. So I'm going to copy this entire message, whatever is generating over the console, and I'm pasting it over the document. Okay, so here what I'm doing, I'm pasting document. Let me create one document, new document. Here is, and let me create a new one, and I am going to paste it over here. See guys, this is a message. Let color. First of all, let me size, and here I see this is my complete agent state. Okay, and at the end we are generating output. So see, first my message is going to the AI assistant. This is my human message. Okay, inside the content you can see this one. Then it is coming to the tool. So tool is what tool actually, oh, sorry, this is my AI message. Then it is coming to where? It is coming to the LLM with tool. So LLM with tool actually it is generating this particular output, means it is saying I cannot generate an answer, go to the tool. Okay, so tool, what it is doing, my retrieve tool actually it is going to fetch the output from the retrieval. Okay, retrieval node, and this is my content. Here is my content. You can see it's going to fetch this particular output from the retrieval, right? Now after fetching it, if this is a relevant, I am going to check the relevancy of this particular data. It is giving where it is giving to the AI, as it is giving to the generator. Inside the generator I already defined a chain, okay, the RAG chain. So here you can see this is my final answer which I am able to. So this is what, this is my complete state. First AI assistant, and the AI assistant, inside the AI assistant LLM with tool is generating this message. Then this is the tool, okay, tool message. Then finally after checking the relevancy it is going to the generation, and then here I am getting my final. I hope so, guys. This thing is pretty much clear to all of you. You can check out with the other messages. Let's say here I'm saying app invoke. Here I'm saying what is a what is a prompt engineering. You can ask any sort of a complex question or whatever you want to ask. Let's say what is a prompt engineering? Explain me in terms of agents and langchain. Okay. So if you're gonna ask, then here you are it is calling is calling the agent, document is relevant, generate, and it is generating a final output. So see, this is the final output, which is, so this is what, this is my agent based, means it is interpreting each and everything during uh, during the workflow, and once everything is fine, then it is going to be generate output. So let's do one thing. Let's try to ask some out of like out of what I can do, out of document question, means which is not related to the given document. Okay, so here I'm asking, uh here my question is going to be very, who is, what is a capital of Delhi, sorry, India. So what is the capital of India? Simple question. Let's see what I will be getting over here. So here guys, see, I am calling the agent. So now it is saying document is not relevant, means whatever document we are generating now from the whatever means, see, this question is not at all related to the data which we have kept inside the database, right? So it is saying document, whatever document is fetching now, whatever document this based on this question, whatever document we are fetching, it is not relevant to this one, simply it is saying to me. Then it is transforming the query. See, this is the transformation of the query, the internal semantics, what is the capital of India and all. Okay, and here you will be able to find out we are, it is not generating it. Why it is not generating anything, guys? So see over here, if you will look into the AI agents, okay, so which model we are using? We are using a GMA model. So through this AI agent, actually we are giving a too heavy context. Okay. And because of that, actually it is not able to like generate the final output. So what you can do here, actually you can mention the like logic. Uh, if you are using the low quality model, in that case, what you can do, you can mention the uh, custom logic as well. Means if there is a rewrite query, if query is coming from the rewrite, so instead of calling this LLM bind tool, okay, instead of calling this LLM with tool LLM, you can call the simple LLM only, right? Let me show you how basically you can do it. So see, this is the like this kind of condition actually you can define. I just written one condition. Let me give it to you. So it might work. See, it's an agent, so you can make a logic according to your requirements. Okay, or you can use any heavy. You can use any heavy model which can understand everything in a more efficient way. Okay, This thing I tested with the Grok, with the Gma model, it was not able to understand. At the end, whatever thing is coming to this LLM with tools, okay, the entire message, it is not able to decode everything. So that's why it is not generating anything, which is good for us. Means if document is not related, it is not generating. But we have to answer the question. Let's say any cost, we have to answer the question, right? So what we can do, we can define these type of condition. So here what we are doing, see, whenever message length is going to be more than one, in that case, what we are doing, we are taking a last message, whatever last message there, okay, and we are passing it to the LLM, simple LLM. And here we are not calling this LLM with tool. This will be called whenever, this will be called when it will be called, tell me when it will be called, whenever the first time message is coming. Okay, at that time we are checking, okay, whether I need to call the tool or do I need to generate a response directly, right? So here, the message is coming, we are checking, it is bind to the tool, and finally what we are going to generate, we are going to generate a like a response, and then further thing is happening. And let's say the messages come, let's say we are getting a message after this rewrite and all, after rewriting a query and all. So at which stage we would be, at this particular stage we would be, see this particular stage, let me tell you this stage, okay, this one, AI message, means it's going to be transform the query. Now we have transformed the query, then we'll come back to this AI assistant, and here we'll find out, okay, message length is more than one, means the list length is more than one. So what we'll do, we'll simply fetch the question and we'll pass it to the simple LLM instead of the LLM with, okay. And here if you want to define any sort of a prompt, you can that also, getting my point. So let's take our example of the prompt. So here I'm going to define the prompt. So let's say what I'm doing, just a second. This is going to be my prompt. Okay, inside this one. So I'm saying you are a like very simple prompt. I'm writing over here, you are a helpful assistant. Whatever question has been asked to you, asked to find out that the given question and then answer. Okay. So here is the question. So let me write this thing. Here is the question. Now what I'll be doing, I'm going to be removing this part and fine. So this is now, this is not required, I think. So let me remove this thing also. Okay. So now what is thing, what is the required thing? So here my question is required. Let me pass it over here. Oh, just a second. This is the one. Now I hope so everything is fine. Okay. Yeah, it seems fine. Now we don't require this question as well. Let me remove from here. Great. Now we have to create a chain. So chain means we have to return a prompt first. So let me write a prompt. That prompt is okay. Just a second. Template. Here is a template. Then chain response and all. So guys, what we required over here, we required the LLM. Okay, so here I'm going to replace it with the LLM, and this thing is going to is with the chain. The chain is going to be invoke, and here I have to invoke this particular chain, right? So let me do one thing. Let me define prompt template is fine. So this is called my prompt. Prompt is perfect. Chain invoke. How to chain? And where is the chain invoke? Yes, this is here. I just need to pass this question. Okay, so very simple thing, and let me close it. This is what, this is my question. Okay, and where I'll be getting my question, so here I'll be getting my question. This is my question. Lost this question. Okay. LLM dot bind tools. Here tools message length is going to be one. What I'll be doing, I'm the question. This is my code. I hope so. I have written each and everything, and now it is Perfect. Okay. The last message, this is going to be a last message. Last message actually, we are going to fetch content. Okay, perfect. So this is my complete logic which I return, which I return for the simple LLM. Now let me check whether it's working fine or not. This is fine, this is fine, this is fine. This workflow is fine, this is clear, clear, clear. Everything we have added as expected. Now let's try to ask this question. There's a capital of India. Call agents, okay, transform query, document not related, so here. You're absolutely right to improve question in a multi direction. And in the original question, we interpret version, no room ambiguity. Okay, so see, it is giving me answer, but it's not able to decode the answer. Yeah, it is giving me answer, but it's not able to decode the meaning of this. But so likewise, we can make a changes. Okay, we can write any sort of a logic like this. Getting my point, right? So either you cannot get any answer, or else you can get an answer like this, like using this logic, or else use a good model which can understand the logic or reasoning in a better way. I hope so. You understood this agentic RAG. Now I will meet you in the next video. Until guys, thank you. Bye bye. Take care, guys. So if you haven't subscribed the channel so far, please subscribe and please support the content. Please support. I'll be coming up with this type of very soon.